While the internet is busy arguing about ChatGPT versus Claude, Google quietly revealed something far bigger. They're not racing to build a better chatbot. They're building a unified intelligence, and according to DeepMind's own research, it starts coming together by 2026. Almost no one is paying attention. By the end of this video, you will be... While most of the AI conversation is focused on which chatbot sounds smarter, Google has been publishing something much more important. Between Google I/O 2024 and a series of DeepMind research papers released over the last 6 months, they've quietly outlined a strategy that most analysts are seriously underestimating. This isn't about a single model or a flashy demo. It's a structural shift in how intelligence itself is being built. And if even part of this roadmap holds true, the next 18 months are going to reshape what AI can actually do. So let's break down what Google is really building, why it's fundamentally different from OpenAI and Anthropic, and why 2026 could mark a turning point most people won't see coming. Google's strategy revolves around one core idea: convergence. Most AI companies today build specialized systems. One model for text, another for images, a separate system for video. Later, they try to stitch them together. That's how OpenAI evolved: GPT for text, DALL-E for images, then gradual integration. Google did the opposite. Gemini was designed from day one as a single, unified, multimodal system. Text, vision, audio, video, and code aren't separate modules. They're all processed through the same underlying intelligence. This distinction matters more than it sounds. When OpenAI improves one capability, progress is additive. You get one better feature. When Google improves reasoning inside Gemini, every modality improves at the same time. Progress becomes multiplicative. That means improvements don't stack linearly. They compound. And the longer this approach runs, the wider the gap becomes. You're no longer racing one model. You're racing an entire system that's advancing across every dimension simultaneously. That's the theory. But where does it actually show up in the real world? Robotics is the clearest example. Google hasn't gone viral with robots doing backflips, and that's intentional. Their focus isn't hardware spectacle. It's transferable intelligence. Their robotics models are trained to perceive environments, plan multi-step actions, and adapt to new situations without being explicitly reprogrammed. Tasks like sorting objects or organizing spaces may look simple, but they require spatial reasoning, memory, and goal planning, the same capabilities needed for complex real-world work. The real breakthrough is this: Google isn't training separate models for each robot. One model can transfer across multiple robot platforms. Once intelligence is solved, scaling to new hardware becomes a deployment problem, not a research problem. That's how you get to a future where a household robot doesn't need detailed instructions. You describe the outcome, and it figures out the steps, adapts to your environment, and improves over time. That isn't science fiction. It's a direct extension of what Google has already demonstrated in labs. The same convergence principle is transforming images and video. Models like Imagen 3 and Veo 2 don't just generate content, they reason about it. They generate an output, evaluate whether it matches the prompt, identify errors, and refine the result in a loop. Accuracy becomes iterative problem solving, not chance. Applied to video, this enables something far more powerful than prettier visuals. These systems can maintain consistency across scenes, understand physical interactions, and respond intelligently to natural language feedback. You're no longer prompting, you're collaborating. You describe an idea, watch it take shape, then say something like, "Make the lighting more dramatic in the third scene." And the system understands exactly what that means within the context of the entire sequence. That same intelligence is now moving into real-time assistance. Project Astra shows what happens when an AI can see what you see, hear what you say, and understand context as events unfold. Instead of answering isolated questions, the system observes your environment and provides guidance while you're actually doing something. Fixing a device you've never repaired, learning a new skill, cooking, coding, building. The AI adapts its instructions based on what it sees you doing, catching mistakes before they become problems. As latency drops and reasoning improves, this stops feeling like software and starts feeling like having an expert beside you, watching and helping in real time. But Google isn't stopping with the physical world. Their research is moving toward world models, AI systems that generate entire interactive environments, not just images or clips. With systems like Genie 2, you can move through generated worlds that remain consistent, remember what happens, and follow logical physical rules. These environments aren't just visuals, they're simulations. That matters because simulations become unlimited training grounds. Robots can learn safely. Emergency scenarios can be tested without risk. Education shifts from watching to doing. Each generation of world models isn't a small upgrade. It's a qualitative leap. Now imagine combining all of this with autonomous collaboration. Google is developing multi-agent systems where different AI agents generate hypotheses, test them, validate results, and iterate without human intervention. These systems are already being used internally for research, code generation, and security analysis. By 2026, they won't just assist science, they'll accelerate it. Think of AI research teams running nonstop, exploring thousands of possibilities in simulation, and surfacing only the most promising results for humans to evaluate. That's not replacing scientists, it's amplifying them. So why can't everyone just copy this? Technically, they can. Strategically, it's far harder. Google has decades of research infrastructure, massive compute resources, and proprietary data from search and YouTube. More importantly, they committed early to unified multimodal architectures. Retrofitting Convergence onto systems originally designed for text is possible, but slower than building for it from the start. And Google isn't just building models, they're building an integrated stack linking robotics, simulation, real-time assistance, and autonomous agents together. Competing with one component is doable. Competing with the entire ecosystem at once is exponentially harder. None of this will be perfect by 2026. Training costs are enormous. Safety and alignment remain open challenges. Real-world deployment always exposes edge cases labs can't predict. But the trajectory is clear. Google isn't chasing features, they're building an intelligence platform, and if even half of this roadmap materializes, 2026 will feel fundamentally different from today. So what should you watch for? Look for robotics moving beyond controlled demos. Watch for video models that support real-time collaboration. Pay attention to multimodal assistants becoming consumer-ready. And track whether agent systems begin contributing to real scientific discoveries. Those signals will tell you whether this convergence strategy is truly working. The AI landscape in 2026 won't be defined by who has the best chatbot. It will be defined by who builds the most capable unified intelligence. And now you know exactly what to watch for. If this breakdown helped you see what's coming, subscribe, because we'll be tracking every one of these shifts as they happen.